Fine, fine. Almost everyone able to hear me. Everyone is online. Okay, fine. Yeah. Yes, let us start session. See, yesterday's session is 9:30 p.m. Yes, yesterday Java introduction. So yesterday's session. Yes, what is Java? Java is an object-oriented programming language. Yesterday discussed about this. Yes, I saved that file. Yesterday, what are things explained saved here? First version of Java JDK 1.0. So 1.0 released in the year 1995. In the year 1995. First version of Java in the year 1995. So one second. Let me mute all. So fine. Yeah. Let me review yesterday topic. Yes, first of all, let me review yesterday topic. After that, we'll go to new topic. Okay. See, what is Java? Simple answer. Java is an object-oriented programming language. Okay. Yes, first version of Java is JDK 1.0. JDK stands for Java Development Kit. Okay. Yes, Java Development Kit. JDK 1.0 is a first version of Java released in the year 1995. 1995. Okay. Yes, 1995. That time I was in engineering second year. Engineering second year. I know the birth of Java. Okay. Yes, already I was in software field. 1995 engineering second year. Computer science engineering second year. Okay. JDK 1.0 released with main features. Yes. Today we should discuss about these things. Yesterday complete Java overview given here. Yes, today we'll discuss one by one here. So independent of platform, these are the main features of Java. Independent of platform. See JDK 1.0, 1.0 released with these main features. Independent of platform, portability, next whoops language, scalability, and then security. So these are the main features of Java. These are main features of Java. Java released with these main features. Okay. Next, JDK 1.0 released in the year 1996. Next year. Yes, JDK 1.1 Java divided into three editions. SE standard edition. Next WE enterprise edition. Yes, ME mobile edition. Java SE, Java WE, Java ME here. JSE. So previously we used to call it JTSE, J2W, JTME. Now we are calling as JSE, JW, JME. SE means standardization, W means centralization, ME means mobilization. See here. So JDK 1.1 divided into four editions like this. Next JDK 1.2 release, next JDK 1.3, next JDK 1.4, next JDK 1.5. Yes, major changes were done. In this version, major changes were done here. Okay. Yes, here. Yes, it's a Tiger version. It's called as Tiger version. Here, released in the year 2005. Finally, Java got its access to JDK 1.5. JDK 1.5, one more edition added. Yes, added one more edition called Java FX. Yes, one more edition JFX means Java FX. Okay. Yes. Finally, Java consists of four editions. There are four editions in Java. Yes, Java SE, Java Enterprise Edition, next Java Mobile Edition, Java Standard Edition, Java Enterprise Edition, Java Mobile Edition, Java FX. Okay. Yes, Standard Edition, Enterprise Edition, Java is very strong. It's a king. Development of enterprise application, Java is king. Yes, when come to mobile applications here, mobile edition Java is poor. Yes, in mobile application development, yes, Android is a king. Android provides many number of features compared to Java. Okay, Java and Python both are very poor in mobile application development. That case we can use Android. Okay, next FX. Java effect. This is using for visual effects. This area also Java is very poor. Java is strong in this area. Standardization and derivation. This area Java is very strong. In this area, Java is very strong. In this area, Java is very strong. Okay, fine. Now, let us take one by one. Yes, what are the SC features? What are the W derivation features? We'll see one by one. Yes, yesterday discussed already. Okay. Yes, same thing, just repeating. Standardization. Features of standardization. Yes, core part, compiler parts. Compiler part like data types, operators like this. Next, oops features. Next, string buffer, these things here. Data conversions, object wrapper classes, except running IO streams, collections, networking, multi-threading. Yes. Next, all these things comes under SE. Yes, our syllabus is SE. We are going to discuss about SE. Yes, these are our syllabus. Our syllabus SE. Yes, SE syllabus we are going to discuss up to this. Multi-threading, next Java 8 and 9 features. Next, finally one project and interview questions. So this is our syllabus. Next, even JDBC also comes under SE, but it's not our syllabus. That is advanced Java. Okay. Next, AWT updates outdated. Yes, up to this is these are SE features. The 13 topics here. 13 topics, these are SE features. SE features. In SE, AWT updates outdated, no one using. JDBC also comes from SE here. Okay. Next, integration. Solid, JSP, EJP, RMI, Java Mail API like this. These are integration features. Apart from the framework, they are the frameworks in Java. Struct framework, Spring framework, Hibernate. Next, Hadoop framework, Spark, Ignite. Next, Angular. They are the different frameworks in Java. So this is complete overview yesterday given. Overview given. Now let us start from the beginning. Let us start. Let us take points wise. So first JDK 1.0 released with main features. Right? Yes, independent platform, portability. Yes, groups language, scalability and security. Now these features we should discuss. Today's topic is about this. Java features. So what are the features of Java? Okay. So yesterday just only JDK contents explained. JDK contains what? See. So what is exactly JDK? See, JDK contains what here? SE, next integration, next ME and effects. There are 4 editions, right? Yes, SE contains what? Next, enterprise edition contains what? Yes, means contents of JDK expand, just only contents. JDK contains what? Okay, that list of contents expand here. Okay, now let us start with features here. First one. So first one, let us start with these features here. Java features. Features of Java. Yes, features of Java. Yes, features of Java. Let us start with Java features. So what are the main features of Java? Independent of platform, portability, groups language, scalability, and security. Okay, let us start one by one here. So first of all, what is independent? First about independent platform. About independent platform. Yes. 1 second. Yes, independent platform. Simply I can explain like a platform is base. Platform is base here. So independent platform is independent of Java is an independent OS. Simply I can explain like that. So I can go to next feature like portability. Portability is running anywhere. Like that I can explain. That is not correct way. Yes, how it is independent platform we should discuss. Java independent platform means independent of operating system. Platform means OS. Yes, independent platform means independent of operating system means Java working on any OS. Next, portable means Java running on anywhere. Java running anywhere. Simply like that I can explain. I can go to next topic. No, that is not my way here. Okay. Now, how is Java made as independent platform? Yes, we'll discuss internals. Java internals. So internally here, how Java made us independent platform? Yes, 1 second. To understand this one here, independent platform. To understand this one here, yes, we should start from basics. If there are some certain basics in software, some basics are there. If you know that basic, then easy to understand these features here. Easy to understand this independent platform. Yes, in that basics here, yes, what is OS? You should know about OS. What is OS? How OS is working? Okay. Next, what is interpreter? How interpreter is working? Yes, what is interpreter? Okay, interpreter. Next, what is compiler? Yes, he must have this knowledge here. Otherwise, he can't understand independent platform. See here, simply I can explain definition. I'll go to next topic. So, but that is not my way. Internally, each and every topic in depth I will explain here. I'll go very in depth here. So, to understand independent platform here, first of all, you must have what is OS. You must have knowledge of OS. Next, what is interpreter? So next, what is compiler? Next, what is exe file? What is exe file? Next, what is Java dot class file? Yes, you must have this knowledge here. Next, apart from this, yes, what is object-oriented programming language? See, next, OOPS language, right? To understand OOPS language here, yes, you must have the knowledge of generation of languages. Generation of language. Generation of language. Generation of language. Okay, these are all the basics. If you know that basics, then easy to understand all these features. Because simply definitions I can explain, but that is not correct. Just learning definition no use. Yes, like an experienced guy, you have to explain. Like an experienced guy, you have to explain your topics. Yes, when you're facing interview, yes, you have to behave like an experienced guy. You have to, yes, talk like experience. When you will get the experience, if you have the in-depth knowledge. Yes, let us go one by one. Okay, so what is OS? What is interpreter? What is compiler? What is exe file? What is dot class file? Generation of languages. Okay, like different language like functional oriented language, object oriented language, object based language. Like that, there are different kinds of languages. Yes, all that kinds of languages we'll discuss. All that kinds of language, different kinds of language we'll discuss here. So we'll see all that basics here. Okay, now I'm starting from basics. So before going to Java features, there are some software fundamentals. After finishing that, we'll go to Java. Okay, see, I'm starting from very beginning now. Yes, even beginner also can understand my classes. Non-IT background guy also can understand my classes. I'll start from the beginning, then I'll take to finally I will take the high end. High end. Okay, high end means like a by the finishing course, you should be in a position to put up minimum 3 to 4 years. That level I'll expand by the time of finishing course. Now, starting from basics. See, here I'm starting from very basics. See, computerware. Computerware basically two categories. First one, hardware. Second one, software, right? Hardware and software. What is hardware? Hardware, these are physical components of a computer. Hardware, these are physical components of a computer like keyboard, mouse, hard disk, monitor, all the hardware components. But this is not our part. Our part is software. We are software engineers. So what is software? Let us see software. What is software? Yes, in software, everything is programmed. In software, everything is programmed. In software, everything is programmed. Yes, it's a collection of programs. It is a collection. It's a collection of programs. It's a collection of programs like C, C++, maybe Java, yes, maybe Python, all the programs. Yes, here everything is programmed. It's a collection of programs. Okay, fine. Next, in software, there are two categories. In software, there are two categories. First one, yes, system software. Second one, application software. System software. Next is application. Yes, application software. System software next is application software. System software next application software. Okay. So here there are two categories in software. So first one system software, next is application software. What is Java? Java comes under which category? Java comes under which category here? Application software. Java is application software. Yeah. So before going to application software, let us see something about system software. Exactly what is system software? What is exactly system software? System software, see this one interacts with hardware components. System software interacts with hardware components. This one interacts with hardware components. Interacts with hardware components. Hardware components. Interacts with hardware components. System software. This one interacts with hardware components. For example, here device drivers and OS operating systems. Device drivers and operating systems. Device drivers and operating systems comes on the scale. Okay. System software. This one interacts with hardware components. See device drivers interacting with hardware, right? Device drivers are to run devices, right? Run devices. Suppose printer, for example, printer. To run the printer driver required. Printer driver, fax machine driver, TV driver, connecting TV driver required. All the drivers are required. Okay, fine. Now, ways. What is ways? Okay, so what is exactly ways? Let us see about ways here. Yep, this is. Try to understand ways concepts here. Okay, just a matter of 5 minutes only. After we go to next topic. What is ways? Yeah, this is very important. Ways topic. If you know the ways here, how ways is working, then easy to understand Java features like independent platform. To understand independent platform, you must know about ways architecture. How ways is working, how it's internally working. Yes, you must have that knowledge. Let us see about this. Okay. Yes, now here question for you guys. Some question for you guys. Some question. Can we run any program without ways? Without ways. Say yes or no. Can we run any program without ways? Say yes or no. Can we run any program without ways? Yes or no. Can we run any program without ways? Yeah, right. Everyone saying no. Correct. You correct. Your answer is correct. No, we can't run. Okay, we can't run. We can't run the programs without any ways. Okay. Now, what is ways? Question is now, what is ways? What is operating system? So, what is ways means don't say operating system simply. Yes. What is ways means don't say simply operating system. What is exactly ways? What is operating system? So, what is operating system? Yes. Yes, anyone can define it. What is ways? What is ways? See, Windows is a ways, right? In my system, Windows ways is there. It's a Windows ways. It's a ways. What is operating system? Yes, anyone can define it. Yes, 1 second, sorry. What is ways? Yes. Let me take Word document for better explanation. Yes, what is ways? Exactly what is ways? Let us see. Question is, what is ways? What is ways? The question. Let us see. What is exactly ways? Yes, someone giving answer. Ways is a system software that manages computer hardware, software resources, provides common services for computer program. Okay, fine. Okay, well and good. It's a software and hardware. One more answer. Software and hardware. Next, interface between hardware and user. Okay, fine. Yeah. What is exactly ways? Yes, I'll answer this. I'll explain. I'm here to explain everything. Don't worry. Just I'm asking your idea. That's it. Okay, just I'm asking idea. I'll explain. So exactly what is ways? Suppose your computer. purchased your laptop. Your laptop, right? Suppose your laptop it's a hardware, right? After purchasing laptop, hardware purchased. After purchasing laptop, next we should install OS, operating system. Next is on top of hardware, operating system. This is operating system. Operating system. This is a operating system. Okay. So first the hardware, on top of hardware, this is OS. This is OS. Okay, right? So here once OS installed, system is ready. Once OS installed, system is ready. Now the system is ready. Okay, system is ready, right? Now my system with Windows based system is ready. System is ready. Once ready, now this OS is responsible to take every request here. OS is responsible to take all the requests. OS is responsible. OS is responsible. Okay. Now see here, hardware on top of that OS. Once OS installed, your system is ready. Without OS, system cannot work. So compulsory OS required. Fine. Okay. Now suppose yes, working with Java. To work with Java, we have to install Java. Yes, on top of OS, we should install Java. Suppose learning C language, install C software. Suppose learning Python, Python software you have to install. Suppose using Hadoop, working with Hadoop software you have to install. Suppose using database, the database you have to install. Okay, the database has to install. Okay, right? Suppose yes, MS Office. Even for MS Office also OS required. So everything is running on top of OS. Okay, like Java, C, or maybe C++, Python, Hadoop. Yes, all these are on top of OS. These are called as what? Application software. These are application software. These are application softwares. These are application softwares. Application software. Yes, all these are called application softwares. See, application softwares for the purpose of application development. 1 second. See here. Yes, software, system software, and application software. OS comes under system software. System software interacts with the hardware components. So OS here interacting with hardware. OS always interact with hardware components. Next, application software. What is application software? Application software for the purpose of application development. Application software for the purpose of application development. That application may be Facebook application or Flipkart application, maybe Amazon online services application, maybe banking application, maybe yes, my company website. Yeah, all the applications, maybe WhatsApp, all the applications. To develop these applications, we need some application softwares like Java, C, C++. Depends on requirements, we can different kind of application softwares. Okay. So here C, C++, Java, Hadoop, all their application softwares, except OS. Except OS, all are the application softwares. Okay, 1 second. Application software, 1 second. So what is exactly application software? Application software, this is for the purpose of application development. So this is yes, application for the purpose of yes, for the purpose of application development. For the purpose of application development. For the purpose of application development. Okay, yes, applications like apps. See, in our day-to-day life, we are working with many applications. Working with many applications like Facebook, it's application. Okay, WhatsApp is an application. WhatsApp is an application. Next, Flipkart. Yes, online shopping, right? It's an application. Next, banking applications, banking apps. Okay. Next, Gmail. It's an application. Gmail. Yes, all the applications. Okay. Suppose website, maybe some company websites or your college websites, all the applications. Yes, to develop these applications, we need some softwares. Those are called application softwares. Application softwares, example, C, C++, Java, yes, Python, yes, databases. Next, maybe Hadoop. Okay, yes, like this, many things. SAP, like this, all these application software. See, except except OS. All are application softwares. All are application softwares except OS. All are application softwares. Application softwares except OS. Except OS. OS means like operating systems like Windows OS, Linux OS, Unix OS. Except these operating systems, everything is application software. See, in software field, many things we are using, right? Many things we are using. Except OS. Except OS, all are application softwares. For example, these are application softwares. Okay. Yes, maybe tools, something like some testing tools. Okay. Yes, next maybe some BA tools like BigQuery, Tableau, warehousing tools. All these are application softwares. All are application software except OS. Except OS, all are application softwares. So application softwares for the purpose of application development. Application development. Okay. Yes, now here, these all are application softwares. All the application softwares running on top of OS. Just all the application softwares running on top of OS. So without this OS here, this cannot run here. For all the application softwares, OS requires. On top of OS, all are running. So like a platform, right? OS is acting like a platform. It's a platform. On top of it, all are running. Yes, we can say platform because on top of it only everything running. So it's a platform. Simply what is OS means first answer. Yes, it's a platform. It's a platform. It's a platform. OS means it's a platform. It's a platform where we can run all application softwares, all application softwares, all application software, all application software. Okay. So OS it's a platform. Simply you can see it's a platform. What is OS means? Simple answer. Simple answer. What is OS means? It's a platform where we can run all application software. Yes, it's just like a platform, acting like a platform. It's a platform. It's a platform where we can run all the application softwares. See, not only platform here, not only platform. Suppose Java program generating some output. Java program generating some output here. First, Java program output goes to OS to then finally output device. Suppose if it is reading from the keyboard, so first the keyboard data goes to OS to Java program. Similarly, so Python program output. So first of all, output goes to OS to hardware. Next input to keyboard to OS to Python program. That's it here. So between application software and hardware, there is a OS, just like a mediator between these two. Okay, so OS is a mediator between these two. See, application software. See, here application software directly communicating with the hardware. No, cannot. Application software like Java directly cannot communicate with the hardware components here. For that OS required. Okay, Java, C, C++, Python. Yes, all the programs. There is no direct communication with the hardware components. Okay, so application software never communicates to hardware directly. There is no direct communication between these two. Okay, see here application software. Yes, suppose any output, that output delivered to OS to output device. Okay, yes, next suppose reading from input device to OS to that application software. Okay, so everything is through the OS here. So OS is the mediator between these two layers, like an interface. Exactly, you can say it's interface. So what is OS? Yes, it is an interface. Next point, it is an interface. It is an interface between. It is an interface between application software. Yes, application software and hardware components. Application software and hardware components and hardware components. Okay, right? Yes, interface. So OS acting as interface. It's an interface between application software and hardware components. Fine. Fine. Next. Yes, sir. Please try to remember all the points. This is very useful for the Java features. While discussing Java features, you must have this knowledge here. How that OS is working, that OS architecture we are discussing now here. Yes, you must have this knowledge. If you know this one, then easy to understand Java features. In Java, this independent platform. Yes, Java features, one of the features, independent platform, right? To understand independent platform is what OS. To understand it here, you must have this knowledge. Please try to remember this one here. Points wise, try to remember this. Next, one more point here. One more point here. See, application software is communicating the hardware through the OS. Or this, what happens exactly here? See, in OS, there is a library. There is some library, input-output library. So OS, every OS has its own library, input-output library to perform IO operations. To perform IO operations between application software and hardware components. So every OS has a input-output library. Okay, every OS, every operating system, see every OS has its own library. Yes, Windows has its own library. Linux has its own library. Unix has. Every OS has its own library to communicate. Yes, to communicate. Yes, between application software and hardware components. Yes, every OS has its own library to communicate between application software and hardware components. Okay. Yes. Next, one more thing here. Suppose Java program running. To run this Java program, that Java program, first of all, it has to link with the OS library. Half linking then communicates with the hardware components. Even C program also. Even C program also has to link with OS library, then communicates with the hardware. Even Python program. So every program has to link with OS library, then communicates with the hardware. Yes, that linking may be static linking or dynamic linking. If the topic I'll explain next. Suppose if it is C language is static linking, Java Python is a dynamic linking. If that concept we'll discuss next. We'll discuss wait. Okay. Now here, yes, every program has to link. So it has to link with OS library. Has to link with OS library to communicate with the hardware components. To communicate with hardware. To communicate with the hardware. Okay, to communicate with the hardware, otherwise cannot. That linking requires. Please try to remember this point here. Okay, this point. Fourth point is very, very important here. See, third point. Every OS has its own library. What is the exact library? Now here doubt library. Library means it's a collection of functions. Library means it's a collection of functions. Library means collection of functions. See, operating systems like Windows OS, Linux OS, Unix OS, all the operating systems developed in C language. C language means C language functions. That C language functions, input output functions, C language functions. Okay. So this library kind of input output functions. Library is a collection of functions, input functions to read data from the keyboard, output functions. Yes, writing output to output device, input output functions like a printf and scanf. Printf is output function, scanf is input function. Okay, so library contains all the functions here. Library is a collection of functions. Every OS has its own library. Every OS has its own library. That library contains input output functions to communicate with hardware components. Okay, that is about library here. Next, every program has to link with OS library. Suppose Java program link with OS library. Half linking then communicates with hardware here. Suppose C program, like this, every program has to link with OS library to communicate with the hardware components. Yes, that linking may be static linking or dynamic linking. Static linking or dynamic linking, we'll discuss. What is static linking? What is dynamic linking? I will explain here. Okay, static and dynamic. The topic we'll see next. Wait. Okay. So this is about OS. I think you understand this OS concept, right? Yes, if you know this concept here, then easy to understand independent platform. Okay, to understand independent platform here, you must have this idea. For that reason, explain about OS, some OS basics. Okay, fine. Now, let us come to this actual topic. See, computer ware. 1 second. Let me take some water. See, computer ware. There's a hardware and software. Our part is software. That's the reason move to software. Software, it's a collection of programs like C, C++, Java, something like this. In software, there are two categories, like system software, application software. What is system software? This one interacts with hardware components, device drivers, and operating systems. Yes, we discussed about device driver and operating systems. Okay, fine. We is also cleared. So next much application software. Application software. See, moving. See, application software. This is for the purpose of application developments. Application developments. Application developments. Like application like Facebook, WhatsApp, all the applications. For this purpose, using some softwares we can develop here. These are application softwares. Except ways, all are application softwares. Okay, right? Next, see, in application software there are two categories. There are two categories. There are two categories in application software. There are two categories. There are two categories. There are two categories. First one, two categories. First one, front end. First one, front end. The second one, back end. So front end software and back end software. Front end, back end. So what is front end here? What is front end? What is back end? Front end. What is front end here? Suppose registering some account, maybe Facebook account registering. Suppose email ID. Suppose you creating some Gmail ID. Yes, you have to register it, right? There's a registration form. In that registration form, something like first name, yes, middle name, last name, something like this. Okay, something like this. That forms are nothing but front end. Front end. 1 second. For example, here. For example, see, this is the form. It's a form, filling form. First name, last name, yes, email address. Just fill and register, right? Yes, every day you have to do like this. Fill that form here and register. Once you register here, that will connect to go to meeting, go to training automatically. Go to training automatically. Okay. Yes, at the time of connecting automatically audio, yes, audio enabling and everything enabling automatically. Okay. Now we are filling some information, right? Information. First name, my first name. Yes, next. My last name here. Yes, my email address. Next, phone number, something like this. Okay. We are filling these details. This one is nothing but a front end. It's a registration form. It's a front end. It's a front end. So front end, right? So what is happening? Front end taking data from users. See, yes, here we are providing that information, right? So we are the end users. We are using this application, right? Go to training. Who are using? Who are using this one? We are using. We are using. So we are the end users. We are the end users of this go to training application. End users. So now this form collecting data from end user, right? From us, this is collecting data. So you get, so this is front end here. So front end, yes, it interacts. Front end interacts with end users. Interacts with end users. Front end interacts with end users. Okay, end users and collects data. Collects data from end users. Collects data from end users. Right? Okay. After collecting data, storing some location. Storing data some location. That location comes backend. Okay. Yeah, this data collecting, right? This data collecting, after collecting, stored some location. That location called as backend. That location called as backend. So what is backend here? Backend, it's area where storing all the data. So backend is area where storing all the data here. So backend. Okay, backend. So backend is to store. So this is to store and maintain data. Store and maintain data here. Store and maintain data. To store and maintain. Backend is to store and maintain data. Yes, backend examples. Backend examples, databases, database servers, database servers, database servers and files. Files. Database servers and files. Files means maybe Linux file system or Windows file system or Hadoop file system, HDFS. Of course, HDFS different case that is using for big data. HDFS is for the big data. The different case. Okay. Now to store and maintain data, we can use database servers or files. Front end, back end. What is Java? Java comes from front end. Java is a front end. Java is a front end. Java is not to store data. Java is to collect data. Java collecting data and storing into databases. Java comes on the front end. So now let us move to front end. Our topic is front end. Okay, front end. About front ends. About front ends. Say about front ends. About front end. Front end. Okay. So about front ends. So front ends. Yes, it's a user interface. Collecting data from users, stores in backends. Next, 1 second. In front end, again two categories: languages and packages. Language and packages. Language and packages. Language and package here. Packages. Package is ready-made and ready to use. Like MS Office. MS Office comes on the package. Ready-made and ready to use. No programming, no code here. Nothing required. Languages. In language, we should write the codes. Languages, we should write some programming. Language is not just a programming here. It's a programming part. It's a programming. It's a programming. In packages, no programming. In package, no programming. It's ready-made and ready to use. In language, it's a programming. Okay. Yes. What is Java? What is Java? Is it language or package? It's a language. Java is a language. Java is language. So let us move to languages here. Our topic is now languages. Languages. So languages. Let us take about languages. Yes, now question is, what is language? What is language? Simple answer. Just a media of communication, right? Language is a media of communication. Just a media of see. We are speaking many languages like English, Hindi, maybe Telugu, Tamil, something like this. Different language. Why? Communication purpose. Yes, expressing our ideas just for communication, right? For the purpose of communication. Okay, it's a media of communication. So what is language? It's a media of communication. Language is a media of communication between two living things. Two living things. Maybe human being, maybe animals, maybe trees. It's a media of communication between two living things. Okay. Yes, now let us come to software. In software languages, see, in software, we are understanding some language, right? Yes, our language software, in software, our language looks like an English language, right? We are understanding some language. For example, here, 1 second. For example, 0.7. One second. For example, see, this is our language, right? It's HTML code. HTML code. It's a user understandable language, like English language. We are understanding this language, but system don't have this language. System can't understand. Now this is user understandable language, like English language. What is system understandable language? Binary code, zeros ones format, binary code, okay, binary code, zeros ones format. System understandable language called as low level language. It's a low level language. Low level, yes, language. Low level language. Next, user understandable, high level language. Yes. languages, there are two categories. In software, languages, there are two categories. Low level languages, next high level languages. Low level and high level languages. Low level and high level languages. So what is low level language? Yes, low level language. It's a system understandable language. It is a system understandable language. Yes. Yes, it is a yes. It is a system understandable language. It's a system understandable language. It's a system understandable language. System understandable language. Okay. Yes, it is in the form of binary code. Yes, it is. Yes, it is in the form of binary code. It is in the form of binary code. In the form of binary codes. Binary codes. Binary code like a zeros ones format. Like a zeros ones format. Zeros ones format here. Zeros ones format. Okay. Yes, zeros ones format. Yes. It's a processor understandable language. It's a processor called as machine language. So it is called as machine language. It's called as machine language. Machine language. Called as machine language. It's called as machine language. Okay. So low level language, it's a machine language. Low level language, yes. Yes, first one machine language. Machine language, one more language is assembly language. Yes. Machine language. Second one, assembly language. There's one more language, assembly language. These two are system understandable language here. Assembly language. Yes. Machine language, assembly language. These two are called as low level languages. These are system understandable language. System internally using these two languages. We are not going to work with this here. This is not our part. We are not going to work on this. System internally using these two languages. Okay. So machine language, it's a first generated language in the software field. Okay. Assembly language, it's a second generated language, second GL, first GL and second GL. Okay. Next, second one, high level language. High level languages. So what are the high level language? High level, these are user understandable language. User understandable language. User understandable languages. Okay. So these are like English language. Like English language. So these are like English language. For example, here, see HTML code, right? Like English language. HTML code like English language. Okay. Next, one more example. Suppose some Python codes. Yes, like English language, right? Python, like a English language. Yep, this is called as user understandable language. It's user understandable language called high level language. So this is high level language. Okay. So high level language like English language. It's a user understandable languages. These are like English language, like C language and C++, Java, Python, Perl scripting. Next, shell scripting, all the languages, high level languages. Those are looks like English language, easy to understand. These are very easy to understand. Okay. Yes. Next, in high level language also we have like third GL and fourth generation of language. There are 4 GL here. Yes, generation of language. How many generations of language? Totally 4 generations. 4 generations. First GL, second GL comes under low level languages. Okay. Next, third GL and fourth GL comes under high level language. Let us see about generation of languages. Okay. Yes, generation of language. Generation of language. Yes, these all are the fundamentals, software fundamentals. Okay. Yes. See, these are unknown facts. Yes. See, 1 second. Some guy having 10 years of experience, even they don't know about these fundamentals. Okay, 10 years of experience Java, maybe 10 years of experience software, they don't know about these fundamentals. Okay, 1 second. Once you started your career in software field, you must have every knowledge. including fundamentals and basics. For that reason, I'm explaining every topic here. So once you facing interview, every question you have to answer. Means you should know every topic, including fundamentals, basics. Okay. Suppose well prepared in Java, practiced and everything fine. Suppose asking some basics. Suppose if you are unable to answer that basics, what happens here? What they will think? Yes, this guy, even he don't know about basics, how he can know about Java? First of all, before going to Java, there are some software basics. So first maybe asking some questions on some basics. So if not answering properly, yes, how they can estimate you like even you don't know about basics, then how can you perform in Java? Somebody will think like that. So you must answer every question, including basics. Okay. So here my intention is you should answer every question. So by the time of finishing your course, you must be in a position to put up minimum 3 to 4 years of experience. That is my intention. That's the reason every topic points first. Each and every topic I'm explaining here. Okay. See, generation of language here. Generation of language. There are 4 generations. First GL, next second GL, next third GL, next fourth GL. There are 4 generation of language. Okay, first GL. Yes, first GL. What is first GL? Yes, it's a machine language. First GL, it's a machine language. Yes, it is in the form of zeros and ones. Okay, binary code. It's a binary code. This binary code. It's a binary code. It's called a binary code. It's a binary code. Okay, right? Yes, second generation. What is second generation here? Yes, assembly language, right? Second GL, it's assembly language. Second GL, it's a assembly language. Okay, assembly language. These two are system understandable language, low level languages. Low level language, system understandable languages. Yes, we are not going to use these two languages. Even not working here. Yes, always you have to work in third generation, fourth generation. Yes, third GL. What a third GL language here? These are procedure. Yes, procedure oriented languages. Procedure oriented languages. Procedure oriented languages. Procedure oriented language like COBOL. COBOL is very old language. Still it's in use. COBOL. Still we are using. Yes, in our office we are using COBOL for the purpose of mainframe applications. COBOL is a language for the mainframe applications. Okay. Yes, procedure oriented language. What is procedure? I'll explain. Wait. What is procedure? We'll discuss. Wait. Procedure oriented language like COBOL, Pascal. Next, basic, Fortran, Pascal. They are very old language. Fortran. Next, Python comes under yes, procedure oriented language. Next, fourth generation. In fourth generation, there are different languages like yes, first one, functional oriented language, functional oriented languages, What is functional? Explain. Functional oriented language. Yes, in fourth generation, first one functional oriented language. What is function and procedure? We'll discuss next. Procedure and function. The topic we'll discuss next. Wait. Yes, in couple of minutes I'll explain. Yes, C is a functional oriented language. Next, Python also functional oriented language. Okay. Yes. Next, second one. Yes, object oriented programming. Object oriented programming languages. Object oriented programming language like C++ is object oriented. Java is object oriented. Python is object oriented. Okay. Next, Scala is object oriented. Next, .NET C# is object oriented. These are object oriented language. Yes, what is object oriented language? We'll discuss. Wait. I'll explain. So next one is here. Next one, yes, based object-based languages here. Object-based languages. Object-based languages like JavaScript. JavaScript is an object-based language. JavaScript. Correct? Yes. Apart from this, next purely objects-oriented programming language. Purely objects-oriented programming language. These are Python. Yes, Python and Scala. Python and Scala. These two comes on this. Okay. Yes. See here. Procedure-oriented language like COBOL, Basic, Pascal. These things here. Functional-oriented language, C language and Python. C and Python. Yes, object-oriented programming language like C++, Python, Java, .NET, CS, and Scala. Okay. Yes. Object-based language, JavaScript. Yes, purely object-oriented programming language, Python and Scala. One second. What is common language in all these? What's a common language? Yes. What's a common language? What's a common language? You observed here. What's a common language in all the areas? What's a common language observed? No one observed? Python, right? Python. Yes, in Python we can write the procedures, we can write functions, we can create objects, even purely object-oriented also can develop in Python. Python is a common this. Let us see one by one. Procedure and function. What is procedure-oriented? What is functional-oriented? Let us see one by one here. So what is procedure? Procedure and function. What is procedure and function here? Procedure and function. So what is procedure and function here? See, suppose some X, spotting ending, between some statements. There are some statements. First statement, next statement, next statement, next statement. Yes, next there's some statement like set of statements. Procedure kind of some set of statements. There are some statements to perform some task. Okay, procedure is a way of writing procedure like this. X, starting ending here. This is procedure. Procedure is a set of statement to perform some task. To perform some task. Okay, procedure. It's a procedure. It's a set of statements to perform some task. Okay, right? Next, function also looks like same. Function, procedures similar. The difference is here. This is a written of some kind here. Suppose if returning some value called as function, this is function, this is procedure. See, procedure and function, yes, both are set of statements. Both are set of statements to perform some task here. Set of statements to perform some task. The difference is here. Function returning a value. Procedure does not return a value. Okay. Yes. Here in this language here, every task by the procedure. Yes, COBOL, Pascal, Basic, Fortran here. Every task by the procedure. That's the reason called as procedure-oriented language. Suppose if task everything is by the function, called as function-oriented. See here in C language here, every task by the function. All are functions. C program is a collection of functions. In C program, everything is function. All are functions. In C program, everything is function. All are functions. Okay, every task by the function. So it's a functional oriented language. Next, when it comes to C++ and Java here, object handles the task. Okay, object handling task. So it's an object oriented language. Here, yes, what's the reason called as object oriented here? Object oriented means it's a OOPS concept. This comes on OOPS here. OOPS is having some features. OOPS. Yes. One second. OOP. So what is OOP? Yes, OOP is a concept. OOP is a concept. It's not a language. OOP is a concept. It's not a language here. OOP is a concept. It's not a language. This concept has some features. Some features. What are the features of OOPS concepts? Like encapsulation, data abstraction. That's okay, fine. That features we'll see next year. First of all, why OOP came to the market? In software, why OOPS concept was introduced? In software, why OOPS introduced? What's the reason? See, before OOPS, we have the C language. Before OOPS, there's a C language. See, here, C is a first high-level language in the software field. C is a first high-level language. 1972, a C language developed in the year 1972 by Dennis Ritchie. So C language 1972 by Dennis Ritchie. Dennis Ritchie has developed at AT&T. Dennis Ritchie, 1972. It's a first high-level language. Okay, it's a first high-level language. So before that, we have the machine language, assembly language. That is not easy to understand. Machine language, assembly language, not easy to understand here. So for that, C language was developed. C is a first high-level language. Okay, yes. C language, some disadvantages. With C language, some disadvantages. What is that here? Data is global. In C language, data is global. Everything is global. In C language, everything is global. Functions global and data global. Everything is global. Yes. So data global means anyone can modify. From anywhere you can modify. Since data is global, yes, anyone can modify. If able to modify anyone, what data corrupting? Corruption of data means there is no security for data. In C language, there is no security for data. Yes, in C language, no security for data. To achieve data security, OOPS concept was developed. Okay, so main purpose of OOPS is to achieve data security. Okay, so initially OOPS was developed with yes, initially OOPS was developed to achieve data security, like features like encapsulation and data abstraction. Encapsulation, data abstraction. Later added so many features. Okay. Yes, any language which is supporting OOPS features, that language is called as object-oriented programming language. OOPS features like encapsulation, data abstraction, method overloading, inheritance, polymorphism. They are the main features of OOPS. So of course, in actual OOPS, I'll explain all that features. There are 10 features in OOPS. There are 10 features. Out of all the 10 features, at least 5 features. Main features like encapsulation, data abstraction, method overloading, inheritance, and polymorphism. Any language which is supporting all the main features, that language called as object-oriented programming language. C++, OOPS language. Java, OOPS language. Python, Scala, these things. Okay. Next, object-based language. What is object-based language? Object-based and object-oriented, both are similar. The difference is here. Object-based language does not support inheritance, except inheritance. Object-based language don't have the inheritance. Okay. For example, JavaScript. JavaScript is a object-based language. In JavaScript, we can define the classes. We can create the objects. We can like object-oriented programming language here. We can define the classes. Next, we can create the objects. But inheritance is not available. Means nothing but code reusability. Some code reusability. Inheritance. Yes, like object. Yes, see, like OOPS language. See, object-based language. JavaScript. We can define the classes. We can create objects. But inheritance is not available. Except inheritance, both are similar. Fine. Next, purely object-oriented programming language. What is purely object-oriented? Purely object-oriented means everything is object here. Everything is object. Everything is an object here. Everything is an object. What does it mean here? What does it mean? Suppose in Java, suppose integer variable int a equal to 10. Yes, it's a variable. Yes, int b equal to 20. It's a variable. Variable, right? Yes, if it is purely object-oriented programming language. Yes, in Java, in object-oriented programming language, this 10 storing inside of the variable. 20 storing instead of variable b. Suppose for float variable, float x equal to some 30.5. So this real number storing into variable, right? A, B are the variables. Same thing. If it is purely object oriented, then this 10 storing like object, not like variable. Like objects, 20 storing like objects, 30.5 like objects, not like variables. Okay, in purely object oriented programming language, everything is objects. Even this 10 storing like objects, yes, 20 storing like objects, 30.5 also storing like objects. Everything is objects. Even basic data types also like objects, Okay, see Python. Python is purely object oriented. In Python, everything is object. No variable concept in Python here. Python, everything is objects. Scala, everything is objects. Yes, when come to Java, Java variables concept available, object concept is available here. But in Python and Scala, everything is no variables concept. In Python, don't have the variable. See, in Python, suppose a equal 10. For this here, one object creates. It's object creating here. Not that a is not a variable, it's an object. It's a class type, it's an object. Suppose b equal 20. Yes, for this also one object creates internally here. Internally creating object. Object means like a somewhat like a box. Okay. So a equal to b equal to for this creating objects. Everything is objects. In Python, everything is object. Scala, everything is objects. Means class type here. 10 is storing like a class type. 20 also storing like class type here. But when come to Java, they are storing like variables, Okay. So purely object oriented means everything is objects. Everything is objects. Okay. 1 second. Scala. Yes, maybe this is new for you. Yes, Scala means scalable language. We are using Scala data processing purpose. Yes, in our projects already we use Scala. Yes, I have a good experience with Scala here. Scala using with big data applications. Big data like Hadoop and Spark. Scala is a language used with Spark framework. Okay, Scala for the Spark framework. See 1 second. In big data applications here, there is a Hadoop framework is there. Next Spark framework is there. Spark framework. For Hadoop, Java is the language. For Hadoop framework, Java is the language. For Spark framework, Scala is the language. Scala is the language for the Spark framework to process big data. For the big data processing. For big data processing, can Scala. Okay. See, Scala is equal to here. Java plus Python is a Scala. If you know the Java and Python is a Scala simply. Scala provides the features of Java plus Python both. Scala more than both of these. Okay, Scala providing Java features plus Python features plus both here. Okay, if you know the Java and Python, Scala is very simple. Scala becomes very easy to understand. Okay, so Scala is a Java features plus Python features is a Scala. That's it. Okay, yes. So these are different languages like first generation, second generation, third generation, fourth generation. Okay, right? Fine. They are generation of language. Okay, fine. Now here, high level languages. Next, low level language. High level. See, this is high level language. This language has to convert into system understandable language. Who will do it here? Who will convert? Yes, maybe HTML code. Okay. Yes, maybe some Python code. It's a high level program. This program has to convert into binary code. Maybe Java program has to convert into binary code. C language has to convert into binary code. Who will convert? Who will convert from high level language to binary codes? Either compiler or interpreter. Either compiler or interpreter. Either compiler or interpreter. Okay, so either compiler or interpreter converts from high level language to binary. Okay, see, compiler, interpreter both are converting from high level language to binary codes, but there's a lot of difference. Okay. Generally, anyone says that interpreter means line by line, compile is whole program. That's okay, fine. I'll agree with that. You yes, but there are a lot of difference. Many differences are there. There are many differences between interpreter and compiler. We'll discuss. We'll discuss page. Okay. One second. Let us go to documents. Yep, this is document. See, need not write any running notes. Running notes is not necessary. You can follow document. Yes, well prepared document is there. Just you try to follow document here. Well prepared document available. Just you follow document here. See, introduction to software. Today topic. Software is a collection of programs such as C, C++, Java, something like this. Software basically two categories. System software, next application software. System software, it interacts with hardware components. Example, device drivers and operating systems. Application software for the purpose of application development like C, C++, Java and all this. See, what is device driver? Here explained. Same thing, whatever we discussed. What is OS? Here explains. Okay. Yes. Yes. Hardware. On top of it, OS. On top of it, application software. Same these topics were discussed. Correct? Yes. Next year, our topic is application software. Okay. Yes. Topic is application software. So moving to application software. Application software. In application software, there's a front end, back end. There's a front end, back end, right? Front end, back end. Back end to store data. Example, databases and files. Databases and files. Front end, the languages. Okay. Yes. Interact with the end users. Interacting with the end users here. Okay. Yes. Java comes under front end. So moving to front end. In front end, language and packages. Package. It's a predefined one, ready-made one, ready to use. Language, we should write the coding. We should write the programming. Java comes under languages. That's the reason moved language. See, the way I'm introducing to Java. See, computer where there's a hardware and software. Our part is software. So started software. In software, system software, application software. Java comes under application software. So move to application software. Moving to application software. In application software, there's a front end, back end. Java comes under front end. So started front end here. In front end, language and packages. Java is a language. Then move to language here. In languages, high level language and low level languages. High level and low level. Okay, in low level, high level, the generation of language. The generation of language. First GL, second GL, third GL, fourth GL. First and second, it's a low level language. Third and fourth is high level language. Okay. Yes, procedures and functions like this. Yes. Here, compiler and interpreter are used to convert from high level language to low level language. Yes. Okay. Yes. What's the difference between interpreter and compiler? Yes, many points you have discussed. Almost minimum half an hour to 45 minutes required. This is very, very important topic here. Compiler interpreter. If you know about this compiler interpreter, you can understand Java. Yes, Java features. To understand Java features, all the prerequisites. Now we are discussing all the prerequisites. If you know about this, then you can understand Java features. So for that reason, start with fundamentals. Okay. Yeah. So interpreter and compile this topic tomorrow we'll discuss. Tomorrow we'll discuss. Okay. Tomorrow interpreter and compiler. Next about yes features independent of platform how it's working portable these things we continue. Yes. Any doubts? Yes, guys. Are you feeling any fast? Yes. Are you feeling any fast? Is it okay? Is it okay? This base is okay. See, I will explain very clearly. Every topic I will explain very clearly, points wise, in depth. Every topic in depth I will explain, including memory map, what is Java internals, behind of Java compiler, some C++ compiler working, how it's working, including that internals also I'll explain. Okay. Yes. Any doubts? One second. One. Still any doubts? Yes, case any doubts are there? If no doubts, we'll continue for tomorrow. We'll continue tomorrow entering to Java features and all this. Right? Yeah. So that's all for today. So thank you guys. See you tomorrow. Thank you.